here we're using a CLI interface, which is actually talking to an agent that has tools for the HCS10 protocol, just to make it a bit easier. But as you can see, it's trying to connect to this agent. So this agent has its own account. It's connected to the agent. It's retrieving the private topic, which only this client agent and the connecting agent are able to communicate to. And as you can see, it's just added an active connection. So I have successfully established a connection with agent at account ID. And we can also see the specific topic ID over here, which is essentially where the messages will be sent to and from. But there's this new topic that's just been created, 4th of April, that's my time, 3rd of April for you. And as you can see, there's only one message. And again, only the two agents. This has created a what's called a private topic in which there's a threshold key. So one of the two keys, only one out of two of these relevant agents keys or humans keys, whatever, are needed to submit a message. And no one else can submit messages to this topic. But this threshold could technically be one of 6, or it could be one of 10. So you can then have multiple agents inside of a particular topic communicating with each other. That one was sent, so we've got jCall agent sent hello, and then as you can see, it's replied. So the consumer over here has now received that message, and it's replied, hello, how can I assist you today with your Hedera network pen? And we can then do things like create a token called Eliza. This is what I'm testing at. Create a token with Eliza token with Dimble, Eliza, mission supply. And again, this will now be communicating to it over that HCS10 network pop-up. The Eliza agent will be consuming it, hopefully understanding the intent and generating it. So what's because we're using this agent interface above the communication protocol, I think we need to say send a message to the connected thing, create a message. So send it, let's see which tool. Yeah, so now it should be going. And we should also then be able to see it happening over here. Extracted data, symbol Eliza, sort of generating it, executing handler for Hedera create token. This is on the Eliza agent on the server side, and then it will come back with the token that we've created. And looks like
for this year, 2025. Let's begin. For those of you who have registered already, thank you. For those of you tuning in and just hearing about this hackathon for the first time, please go ahead and now. To do so, scan the QR code on the screen or navigate to this URL. We'll add the links to the comment section. I'll introduce myself. I'm Brendan, a DevRel engineer at Hashgraph. You can find me with the handle @BGUIZ on the internet, and I use the same handle within the Hedera Discord too, so come and say hi. I'm one of the mentors in this hackathon alongside some of my colleagues at Hashgraph from Hashgraph Online DAO and some prominent members of the Hedera ecosystem. Today, I'll be talking you through this hackathon. Here's what we'll cover today. 3 main things. First, is what you'll be building in this hackathon. Next, we'll walk through some of the tools and workshops and cover some tips on how to win this hackathon. And finally, some key administrative points. Let's dive in. What to build? Let's start with a really big number, 30K in prizes, with 10K for each of the three tracks. 1 track for HCS10, 1 track for Eliza, and 1 track for Agent Kit or MCP. For track 1, in this track, what we'd like you to build on top of Hedera is 2 brand new technical standards that are great for on-chain AI agents. These standards are HIP 991 and HCS10. Before we get into HCS10, let's first talk about HCS 991, which is important to understand first. So the baseline HCS allows you to post short messages into topics. This is like a message queue, but on a blockchain. HIP 991 adds to this. It allows the owner of an HCS topic to collect fees from users each time a user posts a message to their topic. This is going to be super useful in AI agent applications because all the AI agent needs to do is to read the message from the topic, and that's it. The fact that the message exists on that particular topic that it is monitoring means that the topic owner has already been paid. No need to check for a wallet balance, inspect transactions, etc. Simply, the message exists, okay, boom, let's go. The AI agent already knows that it has been paid for its compute and it can simply focus on doing its work. The other really cool feature is that the fee that a topic collects is not only payable in HBAR, the native currency, but you can also set it to any HTS fungible token. The possibility that this opens up is that AI agents can define their own currency, and that's yet another monetization route. The awesome thing about Hedera is that all this is now baked right in at the protocol level, which makes it super easy for you to start building monetized AI agents on Hedera. HIP 991 provides the baseline infrastructure, so let's get to the actual AI agent part of it. HCS 10 is a standard for building AI agents which communicate with each other and with humans via HCS topics. Essentially, each agent has an inbound HCS topic and an outbound HCS topic. A human prompting an HCS 10 AI agent does so by adding their prompt as a message to the HCS topic. By the way, if the inbound HCS topic uses HIP 991, then the AI agent has already earned revenue from it. The AI agent monitors this topic for new messages, and when it sees them, picks them up, and it invokes an LLM, performs a RAG, calls MCP servers, makes LangChain tool calls, etc., perhaps multiple times. The AI agent does whatever it needs to do for its purpose, and this part all happens off-chain. Writes that as a message to its outbound HCS topic. At this point, the human who originally prompted it, and perhaps even other AI agents built using HCS 10, read the outputs. What this means is that we have got on-chain human-to-agent and agent-to-agent communications happening on the blockchain, and it's all enabled through HCS 10. If you would like to learn more about HCS 10 and how to use it together with HIP 991, who better to hear it from than the original authors of the standard and also implementers of the SDK that is used to work with it. So both Michael Cantor and Ty Smith, also known as Patches, will be part of next week's workshop. We'll add the detail for this shortly to the hackathon page. Let's move on to track 2 for Eliza. Here is the link to the before Eliza changed its plugin architecture. But apart from that, it should all be pretty much the same. Also got a live stream with my colleague Jake and Shaw, the co-founder of Eliza. You can watch the replay of that by scanning this QR code. Let's move on to track 3, which is for building with Hedera Agent Kit or with MCP. Hedera has an agent kit, which you can check out at this link. An agent kit is essentially something that sits between the AI agent and some system it needs to interact with in their blockchain. The AI agent or LLM backing it doesn't actually know how to talk to Hedera. So if you enter what is HBAR balance account or for account 001234, for example, as your prompt, you'll likely just get hallucinated data. This is with a pure LLM. Instead, if you connect your LLM inside of your AI agent to Hedera Agent Kit and therefore give it access to direct access to the, interacting with the Hedera blockchain, the LLM will work out that to answer that same prompt as before, it simply needs to invoke functions within the agent kit. The LLM's job then becomes parsing the free-form human text and performing programmatic invocations of the agent kit functions. When the agent kit responds, the LLM's job is to take that raw data, integrate it into its text output. The Hedera Agent Kit is sent to LLM the list of all the things it is capable of doing via metadata, and also it exposes the functions that implement those things. The Hedera Agent Kit, like any other agent kit, doesn't really do anything on its own. It is designed to be integrated or used within an AI agent. And that is precisely what this workshop is about, where you can see it in action. LangGraph.js is a library that is built by the folks at LangChain, and it allows you to build AI agents and agentic workflows by providing the tools to easily manage and interact with the LLMs and to wire multiple nodes together. On GitHub, in the Hedera Dev GitHub organization, find a repo for Hedera AI Agent Workshop LangGraph. In this repo, you'll see that there are a few different agents within it. For today, I'd like to focus on just two of them, which are in the files kitagent.js and mcpagent.js. So kitagent essentially takes the Hedera Agent Kit and extracts all the functions that it exposes, converting them into LangChain tools, and then uses those tools in the AI agent. Scan this QR code to watch the full video on how I built this type of AI agent. Before we get into that, let's quickly run over what MCP is. It stands for Model Context Protocol, MCP, and has defined a way in which AI agents can invoke external functionality in a standardized way. A big emphasis on that last part, in a standardized way. I'd recommend this article by Adi Osmani if you're completely new to the concept. QR code on the screen. One way to think of MCP is that it is like a USB-C connector. Before USB-C, all your devices would transmit audio, video, other data, and electricity to each other using a myriad of different cables. Many times your hardware devices would simply not work with each other because they had a different type of port for their wires. Along comes USB-C and all that disappears. Suddenly, all the devices can connect to each other, at least at a hardware level. MCP is like that, except instead of connecting hardware, it's all about connecting AI agents to various services. It's a universal connector for AI agents and MCP servers. All of them speak a compatible protocol or language. A very popular MCP server is Firecrawl. In this case, you could tell your AI agent something like, get me the first 3 results on traveler.com for flights from Singapore, and the LLM would interpret that, realize that since it has access to Firecrawl, it could make an MCP request that would scrape that data. The results would then be assembled back into a format that the LLM can interpret by the MCP server, which then gets integrated into its chat response. And there's an even more powerful thing, which is when the same LLM or the same AI agent is connected to multiple MCP servers and integrates that data together. That very prompt that I just used as an example, right? That couldn't technically be done entirely using Firecrawl. It would be best to combine that with other MCP agents that know how to do a few more things in addition to that, just scraping. All right, now that we know what MCP is, we can build our own MCP server for Hedera. Continuing in the same repo as before, we can take a look at mcpagent.js. Scan this QR code to follow along with how to do this. Here's a quick recap. Hedera has something called a mirror node API, which is built using an open API specification. These APIs are simple HTTP requests, and because it has been exposed through a standardized specification, it makes it easy to convert. So we're going from one protocol or one standard open API to another one, which is MCP. So this makes it easy, right? We can use a library to perform the conversion from open API specs to create an MCP server. And with that MCP server, we can use another library to wrap around the MCP server to convert that to LangChain tools, and then we can use it in our LangGraph.js based AI agent. Let's move on to code highlights and tips. So this is the repo for the Hedera Agent Kit. And within the repo, I'd recommend skimming the code base in these particular files within the repo to get an understanding of how it works under the hood. I'll leave links to these files, direct links to these files in the comments or descriptions. And likewise, this is the repo for the Hedera ELIZA plugin. Within this repo, I'd recommend skimming the code as well for these particular files. and use that to get an understanding on how it works under the hood as well. Again, I'll leave the links in the description. This is where to find the code for the LangGraph.js AI agent that makes use of the Hedera agent kit. So again, skim the code here or watch the video that was linked earlier. And this is where to find the code for the LangGraph.js AI agent that exposes Hedera mirror node APIs in an MCP server. So again, skim this code or watch the video that was linked earlier. Excellent. Those were all the quick walkthroughs of the code, and a more thorough walkthrough maybe we'll follow up with another video dedicated to those. So these were intended just to briefly orient you through some of the sample code that would be good for you to look at. The videos that were linked earlier, do go check them out for the full walkthroughs. And for HIP 991 and HCS10, hang tight and you'll be in better hands with Michael Cantor and Ty Smith next week. Now, time for tips when building your project and about how to navigate the hackathon itself. As a baseline, in this hackathon, while it focuses mainly on AI and AI agents, remember that this is still a Hedera hackathon. And in that vein, you must build on top of Hedera. And that means that you must use the Hedera SDK or use EVM tools in the case of HSCS. If your project makes use of LLMs to interact with the Hedera network, make use of Hedera Agent Kit. If your project monetizes AI agents, we recommend using HIP 991 for that. If your project involves on-chain communication with AI agents, we recommend using HCS10 for that, for both agent-to-agent comms as well as agent-to-human comms. I'll also point out that the HCS10 and HIP 991, those two standards, they work really well together and in fact are quite complementary. So if you use one of those, quite likely it is a good idea to use the other. We've even designed the tracks to take this into account. Another tip is that your project does not need to reinvent the wheel. For example, you do not need to write your own agent kit that talks to Hedera. Why do that when there already is one? You're encouraged to make use of any open source resources in your projects. This is a hackathon after all, so you will be strapped for time. Therefore, spend it on the most important stuff. In a similar vein, to maximize what you can build within such a short time period, you are encouraged to use AI tools to build. Even give vibe coding a shot if you're up for that. However it is that you choose to build your project, do ensure that it adds significant features or functionality over the baseline. Projects that are a minimal wrapper around an existing tool, library, or framework won't score very well. Do check out the guiding questions section on the hackathon page for some ideas and inspiration for what would make for a good hackathon project. Next, how to navigate the hackathon itself. The number one pitfall that I've seen mentoring and judging blockchain hackathons for the past 6 years now is this: last-minute attempts to deploy onto the network. This is the most common reason that projects do not submit or submit but do not meet the minimum requirements. Pro tip: on the very first day of the hackathon, make sure that you figure out how to get something up on testnet. Create an HCS topic, mint an HCS token, deploy an HCS smart contract, right? Whatever it is that you think your project is going to need, go ahead and do that on the first day. Testnet HBAR is free, so you can get it from a faucet, so there's no reason not to. Then, after developing your full application and you're ready to submit, you won't have to figure out how to do it for the first time, and it'll be more smooth sailing. This tip deserves a slide all to itself. Don't auto-disqualify yourself. This is really easy to avoid. There are more tips as well. Earlier, I mentioned code generation and vibe coding AI tools, for example, Cursor, Windsurf, and Klein. When you use these tools, the most common approach is to start with an empty folder and start prompting from there. There is another way that tends to get better results, which is to use an existing project as a starting point and take it from there. The next few points are around ensuring that you put your best foot forward with the judges when they are evaluating your submission. The two things that all submissions must include are the code repo on GitHub and a demo video on YouTube. In your code repo, in your README, the best thing to do to help the judges quickly and effectively evaluate your submission is to add certain information into the README. Three things in particular, right? First off, create an entities heading and underneath it link to relevant HCS topics, HTS tokens, or HSCS smart contracts with their hashcan URLs so that judges can find your on-chain activity quickly. Second, create a how it works heading and underneath it link to specific functions on lines of code which are the key parts that you would like to emphasize and direct the judge's attention to. Third, for the demo video, you're essentially performing a walkthrough of how to use your project. It could be CLI instructions or GUI instructions. So create a walkthrough section and list those steps so that the judges can manually test your submission. Doing all of this, right, it makes it much easier for the judges to evaluate your project and crucially ensures that they will not miss any part of your project that is important to you. Let's wrap up with some admin, or rather some really important things to remember. The hackathon page will contain the actual date for the full hackathon. These are the key events in that schedule. Note that the virtual demo day will only be for those shortlisted for the prizes. Not all teams will get to participate in that. What makes for a good idea to build at this hackathon? The hackathon page has a guiding question section, which I strongly recommend that you check out for details on this. In any other hackathon, you'd want to build something with good UX and good DX, and the same goes in this one too. But how about the experience for an AI agent interacting with your project? Consider that as well for this hackathon. In any other blockchain hackathon, there's always submissions that do the same few things, or same few categories of things, I should say. What can you accomplish that is new and better precisely because you are using AI? What are the things that you typically wouldn't see before? In this hackathon, consider those as well. In track 1, the standards for HCS10 and HIP 991 are especially important. Definitely incorporate them if you're in that track. There are many other HIPs and HCS standards as well. If you're using any of them, definitely highlight them in the project's README. Finally, ensure that you have on-chain elements. That means that you must have something on-chain on HCS, HTS, or HSCS. You're not on your own in this hackathon. You've got your teammates, of course, but you also have access to resources and mentorship. There's general documentation, hackathon-specific resources, and there are also specific software that you can build on top of or build using, some of which I've highlighted earlier. There is also an opportunity to practice your pitch with mentors. And finally, there's the Hedera Discord with a dedicated section carved out for this hackathon. You'll be able to get help from the mentors there as well. Speaking of mentors, here we are. You're in pretty good hands. How are your projects evaluated? The majority of it will come from the repo that you have submitted plus the demo video. For those who are shortlisted to win prizes, you'll also get an opportunity to pitch. And the full breakdown for this is available on the hackathon page. Now, time for the fun part. If you're successful, you'll win some prizes. And just to recap, there are 3 tracks, each of which has 10K available, right? 6.5K for the best project and 3.5K for the runner-up. That's a total of $30,000 up for grabs. All right, that's all. Thanks for tuning in, and I wish all of you the best luck. And I hope to see some really cool projects coming out of all of you.
All right. Hello, everyone. That was an excellent overview by Brendan. I'm here with Jake Hall, or Jake Cool. How's it going, Jake? Oh, you're a mute.
Good, good. Thank you very much, Ed. How's it going with you?
It's going good. It's going good. But yeah, I'm very excited to be hosting this workshop. And of course, we have this hackathon going full steam ahead. We're in the middle of it. It goes, again, until May 2nd. And then there's going to be a demo day. And of course, Brendan went over all the criteria that we're going to be using for scoring. You have mentors available and many resources and dev tools to build really incredible things. So before we get into the Q&A, Jake, I want to pass it over to you and hear any thoughts, any additional context or explanations that you may want to provide based on what Brendan shared before.
Yeah, so I think what I would just want to get into for those of you who are watching, who are building, first of all, we're going to have a Q&A later on, so get some questions ready. We're also always open for questions via Discord, via X and whatnot, so always keep the questions coming on. We're going to be really hands-on. Keep an eye out for the future live streams and sort of workshops that we're doing. There's going to be more in these upcoming weeks. But something which I think everyone can take away from now is if you're feeling a bit stuck, you're not really sure what AI tools to use. Obviously, Brendan gave an excellent overview just now. But if you head over to the Hedera Dev repo, and I'm gonna share my screen actually so that we can see it together. If we head over to the Hedera Dev repo over here, Hedera-dev, you can find this. All of the workshops, all of the actual plugins and LangChain frameworks and ELIZA plugins and all of that good stuff, you'll find it in Hedera-dev, along with loads of other stuff. So I want to quickly sort of double click into some of the frameworks and the tooling which Brendan spoke about, and where you can actually see it in action via the GitHub. So the first one is this Hedera AI Agent Workshop -ELIZA. If you open this file again, Hedera-dev on GitHub, and it's the most recently updated one. This takes you to a Git pod where you can actually run the Hedera ELIZA agent in real time, and you can actually communicate to an ELIZA agent, which is hooking up to Hedera and then sending transactions and querying the network as well. So this is a good.
What is Gitpod? I think it's a pretty awesome, nifty tool, but just in case we have any hackers who haven't used it before, can you tell us more about what Gitpod enables?
I can do better than that. I can show you. So let's click into it, and yeah, we'll do the setup that we have over here now. Close that for a second. I was testing it earlier. I'm going to need to remember to delete that open router key at the end of this, Ed. And so essentially, literally all you do on that particular repo, just click into it, and it spins up Gitpod. Gitpod is a self-hosted IDE, but not just as a cloud IDE, it also actually runs the code. So we've got this gitpod.yaml file, which is basically responsible for spinning up all of the required dependencies and environment setup that's needed. And that's where Gitpod is really powerful. It gives you sort of the ability to create the environment necessary to run a particular repository. And then also you can sort of guide the user through it. So here, for example, we need an open router API key. So I'm going to copy my one from over here. You also need to enter your, now, oh, that's not taking everything. So you also need to enter sort of a account. So we've got Hedera account ID, and this is just sort of guiding you through it all. Let's paste it from here.
You better rotate that API key after the session, Jake.
Yeah, we're definitely going to do that. And finally, this is an ED25519 account. And this is also testnet. So we've entered the config variables. In the background, it's been installing everything. Now it's actually running it as well. So as you can see, it's taken out AI agent. It's even downloading the embedding model. And then after it's got it up and running, it's then going to run the client. So the client is over here. We can double click into the client. In fact, I didn't even need to double click it, it just opened it for me. And now we have this, we've got this client application, which is communicating to an ELIZA server, and we can chat with it. We can say, hey, what tools do you have? This will tell us all of the tools. It should list all of the tools that it has. I have a variety of tools, cool. So let's say, okay, let's go transfer 10H bar to the account 0.0.800, something basic like that. I don't want to sort of spend the whole session going into this. But the main takeaway for this is that we have working applications inside of that Hedera-dev repo. And what that enables you to do is you can look at the source code, you can get an understanding and a feel for how to integrate and implement our current technologies into your application. And as you can see, it's created this transaction. If we paste it in Hashscan, we'll see that our AI agent 5115088 has sent 10 HBAR to the account 0.0.800. But you can do many other things. You can do many other things. So yeah, that's the particular Gitpod environment. If we go back into the repo, we'll see that it's not just an ELIZA workshop that we have. Another one which Brendan came up with, we just searched for workshop, is the LangGraph workshop. Now, you might be a bit confused, as I am, to be honest, with the difference between LangGraph and LangChain. You can think of LangChain as almost the parent company, where LangGraph is a subsidiary which is focused on AI agents. But LangChain is that overarching AI agent, or it's the overarching large language model framework for building apps that integrate with AI, particularly large language models. But in this repo, we've got a couple of agents that you can just run. So this is not in Gitpod. You can just clone this and run this yourself. But just by running, for example, node agent.js, I think what this does is it spins up some of the Hedera AI agents. Sorry, my bad. Kit agent. This is the more relevant one, because what Kit agent does is it imports from the Hedera agent kit. So you can see, how do I use the Hedera agent kit and all of the LangGraph/LangChain compatible AI agent tools in order to create an agent that can interact with the Hedera network. So just by running this script, you'll be able to essentially create a LangChain LangGraph agent, which uses the Hedera agent kit tools to chat with it. And this is done via the CLI, but you could integrate this, or very similar sort of architecture. You could integrate that into your application. There's also the MCP agent, which again, I remember Brendan was discussing in the call just then. What this MCP agent does is it takes the open router, it takes the open API spec for the Hedera mirror node. Obviously, we use the Hedera mirror node to query things like the tokens on the network, who owns what a particular account information about a particular account. Basically, everything that you write onto the network, you can then read via the Hedera mirror node. And here we see how you can actually take a open API specification and create a create an MCP server, which then uses LangChain and LangGraph to actually interact with that MCP server. So there's quite a few different technologies in here, but the output is a CLI tool where you're able to chat with a LangGraph agent that connects with a Hedera mirror node MCP server to query the state on the Hedera network. It's pretty awesome. And your application probably won't do exactly this, but you will be able to see, okay, how can I get it to work? How can I be guided by these particular repos?
Hey, Jake, quick question here. So I see that you actually have Copilot there on GitHub. So we're talking about AI. One tip that we can provide with everyone, or to everyone, is that if you click on that Copilot little icon, it will bring up an assistant that can help you understand and navigate the repo that you're in. And so basically, you can have this doing what Jake Cool is doing in the session, and explain to you what the repo does, and the different files that it'll find in the code base. It'll explain and get into the purpose of each one of those. So if you have Copilot with your GitHub repos, this is a great way to leverage that integration that helps you use AI to also learn these tools that we're providing for Hedera devs. So just wanted to call that one out.
Well, Ed, that's am I unmuted? Yeah. Ed, you've taught me something then, so that's very helpful. I did not even realize that we had this. So that's pretty cool to know. Yeah, definitely use this. Definitely use this. I'm already a big advocate for it. I think that's basically it. So in terms of, actually, that's not it. No, I take that back. There's HIP 991 AI agent demo as well. So there's a video coming out. It should be live today, actually, I hope. But essentially what this does is it allows you to see an implementation of the HIP 991 Hedera improvement proposal, which, just as a reminder, I know Brendan explained it earlier, HIP 991 allows you to create what we're terming revenue generating topics. So as we all know, the Hedera consensus service is a really unique offering that Hedera has. It allows us to basically create a pub sub Kafka type architecture where we create a topic, we can submit messages of arbitrary data to that topic. It's timestamped and fairly ordered. And that's cool for a whole lot of use cases. Obviously, we saw Atma use it a couple of years ago now, a year to 2 years ago now, for sustainability tracking. And I mean, they were basically doing sort of 10,000 TPS with it, which is really impressive. It shows the quality of the Hedera consensus nodes and the algorithm. But actually, what we've done in the past few weeks is we've created this new proposal, which is live on mainnet and testnet, where rather than, well, you still pay that sort of very low cost fee for submitting a message. It's slightly more expensive when it comes to these HIP 991 topics, but you could also add a custom fee onto the topic, meaning I can say, okay, I can create a topic which has a custom fee, and we can see that being done over here in this index.js file. We can create a topic which topic create transaction, which has a custom fee. So that custom fee can be anything we want. It can be HBAR, or it can be tokens like USDC. And we can specify that every time there's a message submitted to this transaction, to this topic, every time there's a message sent to it, you also have to pay, along with the normal fee, you have to pay a fee of 5 USDC or 10 USDC or 5 HBAR or 5 of your meme coin of choice. And what that does is it means you can then have an AI agent which is consuming that topic, listening to it, maybe using HCS 10 to listen to the topic. And then as soon as there's a message sent to that topic, the AI agent knows, okay, as a matter of fact, I would have received 5 USDC or 10 USDC or 500 meme coin before this even gets sent. So it guarantees that some sort of value has been transferred to the receiving agent, and the agent can then, knowing it's been paid, it can perform its particular action and then respond back to that topic or respond anywhere else you'd like in order to actually do that. I know I speak for myself here, but I would imagine, I'm not a judge, I am of course a mentor, I would imagine if you're able to integrate HCS 10 and HIP 991, the custom fee revenue generating topics, and HCS 10, the decentralized communication protocol for AI agents, if you can couple both of them together, that's going to set you in high standards. That's definitely going to be a very strong submission, because you're going to be drawing in different elements and different features which make Hedera really suitable for AI agents. I couldn't sort of speak about HCS 10 without giving a big shout out to one of our key partners in this hackathon, Hashgraph Online. I'm just going to give a quick sort of showcase to their website where you can see all of the standards, and you can see sort of documentation over here. They also have loads of their own repos which allow you to integrate and interact with HCS 10 much more easily. So let's see if I can learn more. So we should be able to see over here, I'm assuming that we have the repo somewhere. But if not, you can find it on you can find it on GitHub. We go to Hashgraph Online, and we can see the standards SDK, and they also have a agent SDK. But with the standards SDK, you can basically easily integrate the HCS 10 standard and have agents communicating to each other. I've got a lot of my own content, a lot of my own live streams are doing that as well. Standards Agent Kit is another one. So Standards SDK and Standards Agent Kit, this allows you or an AI agent to integrate with some of the standards that they've created, like HCS 10.
That's pretty awesome. So again, HIP 991 is that feature that allows effectively exchange of information and value exchanges all in the same transaction. And then HCS 10 is that standard that takes that to the next level to bring that agent-agent communication and value exchanges. So I think that's going to be super compelling to build great solutions for this hackathon. So as people get ready with questions that they can throw in the comments, there were some questions that came in as well. And Jake, we can probably start there. So Brendan showed us all the different tools that we have available for developers, the Hedera Agent Kit, the ELIZA OS plugin. There are MCP servers that people can create. There is, the workshop repos and many more resources that people will have available. But this question is related to the Hedera Agent Kit and the ELIZA OS plugin. When would someone use one over the other when it comes to those two?
It's a really good question. So I think here it's obviously the thing is we've got so much going on at once, and the AI space is innovating as well. We've got so many different terms, so many different repos doing sort of similar things. So the way that I like to understand it is we've got the Hedera Agent Kit. Now, the Hedera Agent Kit in and of itself does not actually do anything related to AI. What it does is it brings together all of this functionality, which allows you to interact with the Hedera network as a whole, and also protocols on top of the Hedera network, like DEXs and whatnot. It brings it all together in a opinionated way where you don't get all of the functionality. So for example, with the create token inside of the Hedera Agent Kit, you don't have all of the granularity that you do when using the SDK directly. You can't, for example, create sort of really complex tokens which have really complex fee schedules. But what it gives you is it gives you just enough for an AI agent to understand it and for it to easily be integrated into AI agent frameworks. Now, over to ELIZA and then LangGraph, these are examples of AI agent frameworks which use the base Hedera Agent Kit, that opinionated class, that opinionated software, which brings together all of the key functionality in a nice and formatted and consistent way. It uses those, and developers can then use that Hedera Agent Kit to rapidly integrate it into frameworks like ELIZA or like LangGraph. Now, I'll slightly rephrase the question and then sort of answer, when would we use an ELIZA agent versus when would we use a LangGraph agent? My thoughts on this, and Ed, I'd be interested in hearing yours too, what I would generally say is if you want to create an autonomous agent which has a lot of personality and it's able to speak into different platforms like X, Discord, Telegram, other sort of platforms like that. If you want to create really a person, you want to mimic the effects of a person, that's when you want to create an ELIZA agent. Because what ELIZA gives you is it gives you loads of plugins into other applications. Where you might want to use a LangGraph agent is if you've got some very customized use case or a particular user interface where actually you don't need all of this external third-party integration. You just need to have integration into Hedera, transactions, creating tokens and whatnot in your own particular user interface in your own closed environment. You don't need to have a funky personality. You don't need to have a really complex algorithm to sort of give entropy to a particular AI agent. That's probably where you want to use the Hedera AI Agent Kit. So to give an example with people in the ecosystem so that people really understand what we're saying, if you are a wallet developer like Hashpack or Kabila, and you want to provide AI agent functionality into your application, you probably don't want to use the ELIZA platform because it's the ELIZA operating system, because it comes with a lot of stuff which you don't really need. But what you need is really focus. Okay, people just want to create a token inside of their own little wallet, easily integrated. That's where LangGraph might be more suitable. On the other side, if you want to create a AI agent which is responsible for trading or responsible for marketing and responsible, that is being sort of it's more than just sort of interacting with the Hedera network. It's actually communicating stuff. That's where you might want to use an ELISA agent.
That is absolutely spot on. I love what you said about ELISA, and huge team to that team, and the systems that they've developed. But if you want your agent to have personality and the ability to integrate into a large ecosystem of other integrations, I think that is absolutely the way to go, and where the ELISA OS excels. So another question that relates to one of these tools is MCP, right? Model Context Protocol. Can you comment on whether MCP servers are only for local agent development, or if you can actually use an MCP server that is hosted publicly? And maybe, some key words that may come in there in answering that question, maybe STDIO and SSE. So I'm curious to get your thoughts on that.
Yeah, so for those of you who don't even know about MCP, again, Brendan gave a quick introduction to it, but I know we've got some new people here. So MCP, it was actually it's a standard that's been created by Anthropic, if I remember correctly, and it standardizes the way that AI agents can interact with tools. Similar to the Hedera agent kit, the MCP server itself doesn't actually have any AI to it. The AI knows what is available on the MCP server. It's got a particular, it knows how to list what functions an MCP server has, and then it can choose and package up the request to then send it over to the MCP server, which actually does the compute of the particular action, whether it's creating a token, whether it's calling an API, whether it's just retrieving a bit of data. Now, there's two types of instances where you can actually interact with an MCP server. The first one is probably more common for developers, I think. So when let's say I'm vibe coding with Cursor and I want to have the ability to integrate, I mean, what's a good example here? Let's say I want to query, for example, the Hedera mirror. Actually, the mirror is not the best example. Maybe I want to speak to a database. Maybe I've got a database running on my local machine, and I want my AI agent, while I'm vibe coding, to be able to update the database, and I want to be able to have sort of SQL queries which sort of change the format of the table or add mock data to the table. In that particular instance, you can just have an MCP server which is running on your machine, a lightweight MCP server, using STDIO, standard input output. And what this does is it means you don't have to have your MCP server living on someone else's server. You don't have to speak to it via HTTP across sort of the internet. You can keep it localized, and you can just have it specifically for your particular use case. But on the other side of things, you could also use SSR, which is server side, or SSE, which is server side events. So this is a way that you can build APIs, back-end APIs, in such that anyone can come along and communicate with a hosted MCP server. A good example as to where you might want to have a hosted MCP server is, say, the Hedera mirror node, where actually everything's just sort of, you're just reading data, and someone like Hashgraph, the organization which myself and Ed work with, someone like Hashgraph could technically have a hosted Hedera mirror node server, which gives AI agents the tools that they need in order to speak to the server, package something up, and then actually query the mirror node, have that respond back to the AI agent, and the AI agent relay that to the user. That would be useful because it means that a particular developer doesn't need to go through the effort of hosting it themselves and making sure that it's running and all of that stuff. It sort of takes that particular deployment aspect off their shoulder. But of course, there are going to be times where you do want to have your own, where you do want to have it locally, where actually maybe if you're just doing some development inside of the IDE, you don't want to actually be sending your prompts or your package requests over the internet. So yeah, that's sort of the difference between the two. But yeah, it really depends on the use case.
Love it. So just to make sure I'm following correctly, so MCP standardizes how information is exchanged or useful to the model. So things like context logs, commands, gives a standard way for the model to know how to use a particular tool or environment. And then MCP, the protocol itself, doesn't restrict where the server runs, right? You just have to take into consideration the transport layer. And so SDIO for local development, and then SSE, which enables that, you know, public hosting of an MCP server as a utility.
Yeah, and that's a really important point. So actually, you cannot use, if you want to have a public MCP server, or even sort of a private MCP server behind an authentication layer, you need to use the SSE transport layer. You can't use STDIO. Whereas if you're developing locally, you can use either. Typically, people go for STDIO because it's just a bit easier. I think with SSE as well, SSE server-side events, that's what allows streaming. So when you're creating from the user experience perspective, when you're interacting with chatbots and LLMs, it's much nicer for the user to have that stream of tokens coming in, that stream of words. So it's not just them waiting for 20 seconds, like, is something going wrong? And then all of a sudden, a whole lump of text comes. That would be just the typical REST post request response. But actually with SSE, you can actually stream it in. So from the user experience perspective, it's much nicer. But yeah, just to recap, if you want to have a publicly hosted good or a product which is behind an authentication wall, you need to use the SSE transport layer. Whereas if you just want something which people could run locally, that's when you want to use STDIO.
Awesome. All right. One more question that came in is, this one's more on the basic side, but what would you say is the difference between an LLM and an agent? And why would hackers want to build agents with these tools that we've been mentioning?
Yeah, that's a really, really good question. Actually, I think that's an amazing question. Because what LLMs are really good at is if you give them some text, they'll give you a response. They're good for generating stuff. But take an LLM. I mean, this is actually quite a fun activity to do, at least for me. It's a bit of a nerd. But what I really love doing, and what I really love sort of that feeling, is when you have a local LLM, you've got a large language model which you're running locally, and you turn off your Wi-Fi and you chat to it. Because it sort of makes you realize that actually these large language models, they don't connect to the internet. They have no way of going outside. It's if you're an EVM developer, it's kind of like the EVM. If you've got a smart contract, that smart contract is not able to send a post request outside into the internet. It's all contained on that EVM, that Ethereum virtual machine. Similarly, large language models inherently have no way to communicate externally. So if you're just doing tasks like sending a question and waiting for a response, or summarizing particular text where all of that context is internal or is being sent to the LLM, you don't need an AI agent. But where AI agents become a bit more relevant, and where you might think, okay, why should I use AI agents, is to take LLMs to the next level. It would allow essentially an LLM to start doing things beyond just input output, and actually calling external APIs, or calling sort of the creator, interacting with the Hedera network, reading external data sources. And the way that it does it under the hood, all of the AI agent frameworks, they abstract this. But what it's really doing under the hood is you tell an LLM in its system prompt, you've got tool A, tool B, tool C. So it might be, you've got the tool which allows you to create a Hedera token. You've got the tool which allows you to search the internet. You've got the tool which allows you to generate images. And all of that is just in the LLM system prompt. So whenever you then ask a message, you say, hey, ChatGPT, or hey, Hedera AI agent, create for me a token called XYZ. You're not actually just sending that message by itself. You're sending it that message, and surrounded with that message is the ability, is the context saying, okay, you have the ability to call this tool. If someone asks you, create a token, call this tool. So the LLM goes, right, I've got this message, I have these tools, and someone's asked me create a token. So if I create a token, what do I need to do? Well, I need to call this tool. So what it does is then it takes the sort of the unstructured data and structures it, and then just sends it over to a computer like an MCP server or its own sort of local compute, and then it executes a function outside of the LLM. But really all that's happening is the large language model, with its context, with its prompt engineering, it knows what tools it can call. It takes a user's request, it packages it up in the format that the tool wants it. Again, all of this has to be determined. It's sort of invisible to you as a user. And then it goes, okay, this is we're calling this tool now. Let's create that data which is needed, the token name, the token symbol, the token initial supply. And once I've got all of that, I'm going to call this function externally. That then happens outside of the large language model. It returns the response gets sent back to the LLM, and then the LLM goes, okay, we've just created this token, here's the token ID, here's the transaction ID and whatever, and you can check it yourself. But the AI agent, it allows the LLM to actually do stuff just beyond the large language model itself. It allows it to integrate with external services, integrate with things like the Hedera token service, the Hedera consensus service, internet searching, context, everything outside of it. So it becomes pretty useful.
Absolutely. Pretty awesome to see also the maturity and progression that we've seen, in just the last 2.5, 3 years, where we started with the chatbots. Then ChatGPT, I remember when they introduced plugins, and then everybody was developing a custom integration for one particular tool. But then MCP takes the usefulness and the value of agents to the next level by standardizing the tools that are available to a model to an agent to perform multiple actions. And then these protocols like HCS10 and these features and capabilities like HIP 991 take this set of tools to the next level as well by enabling that inter-agent to agent communication and value exchanges as well. So really incredible pace of innovation. And tying it back to the hackathon, these are the tools that enable builders to build the future and the best solutions that they can think of. All right, so those were most of the questions. If there are any last minute questions that come in, please throw them in the chat. We'll be happy to take them. So we'll just give it a couple seconds to see if anything else comes in. But if not,
we've got one in the starred section. I can share it on the screen here.
There it is. All right. So will the communication between AI agents be an IoT solution for energy trading? So for instance, unused solar energy being transferred to needed power sources by AI agents autonomously. Do you want to take a stab at that one?
Yeah, I mean, it sounds pretty, whether it will be or not, if we're going into a future where energy is tokenized and we have really robust energy grid systems where actually it can be possible to take energy from one area where there's overproducing and transport it to somewhere where it's needing more, then I think inevitably AI agents will play a role with that, and they will need a communication layer. But in terms of this is something which I'm quite interested in. I think the main blocker between these things becoming a reality is actually the underlying infrastructure, the national grid, for example, in the UK, which has all of the energy, which transfers all of the energy. It's not up to level. We've got the technology. We can tokenize energy. We can incentivize people to generate their own energy. But do we have the physical wires and cables to do so? I definitely not in England. We don't. But equally, this sounds like a pretty interesting hackathon submission. I think ultimately, if there is something where a human is currently going, let's send over here, let's do this, that an AI agent could do it, and an AI agent could do it for a much more commercially competitive, for a much more competitive price, essentially.
I love that, right? Because tokenization and blockchain can, again, tokenize that energy, and perhaps agents is that reasoning entity that enables the marketplaces for this tokenized energy to take, for those exchanges of energy to take place. And so perhaps the AI agents can accelerate, the tokenization of that energy, and also can accelerate the commercialization and market creation of this tokenized energy. So as you said, a very interesting and compelling submission for the hackathon if somebody wants to indeed implement that. All right, so we are right at time. Jake, any last thoughts in the remaining 10 to 30 seconds?
Well, it's just gone. No, I think, look, keep on asking questions. Don't be afraid to. No such thing as a silly question. We've got channels via Discord. We've got I think we've got an office hours right now with Hashgraph Online. So just join, ask questions. We're getting towards the end of week 1 in the hackathon, so sort of 1/3 of the way done. But yeah, keep on sort of asking questions, and as the excellent advice that Brendan gave in his video at the beginning, don't leave it till last minute. What we saw in previous hackathons, we just run one in Kenya. The people who won are the ones who were committing basically a little bit every single day. So there's no surprise behind that.
Excellent.
And
All right.
scan the QR code. Scan the QR code.
Shout out to Patches there, asking, how is Jay so cool? You know, it's all in the name. It's all in the name.
My name, bro.
Yeah.
Can't help it. Can't help it.
Excellent. All right, excellent.